We're going to be talking about how to use a scale. That is that funny shaped object that kind of looks like a ruler. First off, there are different kinds of scales. There is an architect scale. There is also an engineer's scale. And there's also a metric scale. The metric scale is a little bit easier to see because the numbers that it has printed on the sides of the scale will have a colon in them. The engineer's scale is also using inches, but the subdivisions of the inches are a little bit different. They divide those inches into 10 equal parts. And so in the center of the scale, it will have the word written on it, and it'll say either architect or engineer. And what we do for an architect scale is we start to take our inches and then divide them in half. So if you take an inch and then you divide it in half, you get half an inch. And then if you take that half an inch and divide it in half again, you get a quarter inch. And if you divide that quarter of an inch in half, you get an eighth of an inch. You divide that in half and you get a 16th of an inch. And that's why the architect's scale will have the number 16 on it here. And so here's our 0, and here's our 1 inch. And so halfway in between, that's half an inch. Halfway in between that, that's a quarter inch. Halfway in between that guy right there, that's an eighth of an inch. And halfway in between that, that is a 16th of an inch. So you might be wondering, why do we even use this complicated thing called a scale? The reason we need to use one lies in this question here: how big is a building? And the answer is a building's bigger. Keep going. Bigger, more. Big buildings are much larger than us, and they're larger than pieces of paper that we have to draw them on. As a result, we have to do a small version of the drawing of a building because it would be pretty crazy to try to draw a building at full size. That would require a really big piece of paper. So what we do is we take the size of something in real life and we equate that to how big it's going to be on the drawing. And typically we use 1 foot in real life, and we say, okay, if something is 1 foot in real life, then when I draw it on my drawing, I'll make it 1 inch. And likewise, if something is 2 feet in real life, on my drawing, it will also be 2 inches. And so we use different relationships or ratios or different scales to draw buildings at different sizes. If I was drawing a large piece of land, like acres and acres, I might need to draw it at a scale where 100 feet of real life size equaled 1 inch on my piece of paper. On the other hand, if I was drawing a detail zoomed in really close, I might want to say that something that measures 1 foot in real life will appear and be 3 inches in my drawing. I put these two here in blue because these are the most common scales used in architectural drawings. A quarter inch equals a foot, or an eighth of an inch equals a foot. Those scales allow us to put most buildings, whether it's a house or a medium-sized building, onto one large sheet of paper. So I've taken all the different sides of the scale and I've arranged them in a way that you can see them all together here. It can be a little bit intimidating to see that much information all at once. So let's turn those other ones off. The other common scale that architects like to use is 1/8 of an inch equals 1 foot 0 inches. Remember, that's 1 foot in real life equals 1/8 of an inch on a drawing. If I'm working at 8th scale, I find the part of the ruler that says 1/8 on it. I need to find my 0. Keep in mind that your 0 is not the edge of the scale, and your 0 is not the first line on the scale. The 0 is right here where it says the number 0. Notice that the 0 is in this upper row of numbers. The 0 is not part of these numbers down here. So if I want to measure something in 1/8 inch scale, I find my 0 and I say, okay, it's going to be 20 feet long, so there's my 20. Right? Being careful to ignore these numbers on the bottom because my original 0 was in the top row, so I'm only going to refer to the numbers in the top row. So if I want to draw a line that is 12 feet long, there. If I want to draw a line that is 24 feet long, I start here at my 0. I draw a line that goes to 24 feet. Let's zoom in a little bit more, and we'll realize that there's my 0, there's my 4. So that means that this line is 1, this line is 2, this line is 3 feet. Well, we've already determined that 1 foot is a measurement from there to there. So the measurement from here to here is also 1 foot. So what are all these little lines that are to the left of my 0? This distance here is halfway between 0 and 1, and that is 6 inches. So this distance here would be 2 inches. This distance here would be 4 inches, 6 inches, 8 inches, 10 inches, and 12 inches. The other common scale that architects like to use is 1/4 inch equals a foot. And that means 1 foot in real life is equal to 1/4 inch on the drawing. So to work at 1/4 inch equals a foot, I find the 1/4 inch symbol, and I find the 0 that is nearest to it, recognizing this time that the 0 is on the lower row of numbers. So I'm not going to be paying attention to these numbers because they're on the upper row of numbers. I'm going to start with my 0 right here, and then this is a 2 foot distance, this is a 4 foot distance, this is a 6 foot distance. So if I want to draw a line that is 8 feet long, it goes to there. If I want to draw a line that is 3 feet long, it's going to go to right there, realizing that if this is 2 and this is 4, then this must be 3 halfway in between. If I want to draw a line that is 6 foot 6 inches, I start here at 0, I come across, I find 6 feet, realizing that this is 8 feet means this must be 7 feet, and that this increment right here must be an additional 6 inches. One place that might be a little bit confusing on the 1/8 inch or 1/4 inch scales is this location here, because you can see there's a 32 here and there's a 32 there. And what's happening is the 1/8 inch scale starts with this 0, which is in the top row, and that counts up and gets us to 32. And the 1/4 inch scale starts in the bottom row with this 0. And those begin to collide here when we get 28, 30, 32, all these numbers kind of mixing up together. So just for fun, let's do this. If I'm working at 1/8 inch scale and I want to draw a line that's 32 feet long, it would be this long. If I'm working at 1/4 inch scale and I want to draw a line that's 32 feet long, I would start at that 0, measure across to here, and I'm using this 32 because it's in the lower row in the same location that my 0 was in the lower row. So here's a few more. Let's say I'm working at 1/2 inch scale. I would find my 1/2 inch, I find the 0 that's nearest to it, and if I want to draw a line that's 9 feet long, I start here at 0 and I come across. Here's my 8, here's my 10, so halfway in between must be 9. That's a 9 foot line working at 1/2 inch scale. Let's say I'm working at 3/32 inch scale and I want to draw a line that's 44 feet long. I come to 3/32, I find my 0, I start to draw my line. I'm coming across, I'm coming across. I want to make it 44 feet long. Do I stop there? Nope, I keep going. And I'm going to here. The reason is that this 44, it's in the lower row and it belongs to this scale here, 3/16. So I'm going to disregard those numbers and I'm measuring across using the top row. That line there is 44 feet long.